Okay, so today we are going to be working on more SohCahToa. The difference between what we're going to be doing today and what we did on Monday is literally just, instead of having SohCahToa just being freewheeling and geometry type stuff, where it's just looking at a triangle and all the sides are positive because we're just working with a normal triangle. Here we are going to be taking these and basically just putting them on the coordinate plane and putting them in the context of being on the XY axis. And the reason why we want to do this, and the reason why we're doing this right now, is because next week we are going to be working on what's called the unit circle. So today we're talking about having the XY axis, and we're going to sort of superimpose everything over there, and then sine and cosine and all those might be positive, they might be negative, it just depends on the context. And then once we have a unit circle, we're going to have everything basically be marked by the radius of a circle, and we'll talk about there are certain angles that are super duper important that that we're going to talk about because they have consistent, easy to find, easy to write down values. It's not just like a big mess of decimals like we've been doing. Okay, so a couple things before we get started. Thing number one, we need to talk about what are called coterminal angles. And basically, let me get... see if I can do this and not have it be gross. Close enough. Not bad for having to do this all freehand. All right, so imagine, if you will, a line. Tell me how. Guess I gotta use this one. Sure. Let's have it be a better color though. So let's say we've got a line coming out of the coordinate plane like this, and the angle measure, let's call that, that looks like about 50 degrees. Yes, we are. Very good. We are, in fact, working with terminals, and I'm about to talk about. Let me see. Let's see if we can. Here. So this is 50 degrees. This 360 and 50 makes like 410 degrees. Do you know what these two angles are called? So the big hint is that the fact that you said the word terminals was like, okay, maybe you know it, but that's fine. I haven't taught it to you yet. So these two angles, 50 degrees and 410 degrees, are called coterminal angles. And the reason they're called coterminal, obviously, is because they end at the same terminal, right? They end at, I think technically we would call it a terminus. Because that's where they both terminate, at the terminus. But that's neither here nor there. Basically, if two angles are 360 degrees apart, or 720 degrees, like exactly one spin or two spins or five spins apart, you can call them coterminal angles. So if we go backwards, starting from 0 always, and we come back to this spot here going the other way, that's like negative 310 degrees technically. All three of these angles, the red angle, the brown angle, and the green angle, are all coterminal because they all start at 0 and they all work their way around. But all you need to worry about when it comes to this sort of stuff is, are they some multiple of 360 apart? Like 410 and 50, that's 360 apart. 50 and negative 310, that's 360 apart. If you looked at 410 and negative 310, (360) minus 50 is negative 310. 360 plus 50 is 410. That doesn't feel right. No, that's right. 310. Yeah, because it's 50. All those are going to be 10s. Had to triple think about it. But if you go through and you subtracted 410 from negative 310, you end up with positive 720. And that's a multiple of 360 apart. So all these, so you're going to go through, I think it's like problem number 1, it's going to ask you which one of them is not coterminal with the other ones. All of them but one are going to be like some multiple of 360 apart. One of them is going to be the odd duck out, so pick that one. Okay? All right, let's get into the actual material though now. So, thing number 1 is we talked about sine, cosine, tangent, secant, cosecant, and cotangent in terms of opposite adjacent hypotenuse, right? So the thing of it is, we have other options of how to represent that material, and I'm going to be very honest with you, especially right now. You don't need to worry about having this memorized separately from the other thing, because you don't need it. You've got SohCahToa. Everything boils down to SohCahToa here right now. But the book does bring it up, and so I want to show it to you, because technically, when we start doing more algebra things, it's going to be sometimes easier to explain using this definition, and it's going to be easier to sort of talk about it. But it's the same thing. And in fact, if we talk about it in this way, it actually sort of the exact same thing, and I'll show you why. So sine, instead of being opposite over hypotenuse, they say it's y over r. And I'll show you what I mean by y and r in a second. Cosine is going to be x over r. Tangent, y over x. And then cosecant. Remember, cosecant is the flip of sine. So if sine is y over r, cosecant is r over y. Secant is the flip of cosine, so that is r over x. And tangent is the flip of cotangent. Let me write the right words down. Tangent and cotangent are flips. So that gives us x over y. All right, so here's the thing. What do all these letters actually represent? If we go back to that xy plane thing here, yeah, drawing freehand. It's going to be great. And drawing that terminus, let's put a point here and try and draw a straight line down. You can think about this right triangle just like we're used to. And then this is the y value of this point. This is the x value of this point. And then, as I said at the beginning, we're going to eventually get into talking about the unit circle. This line right here is going to be the radius of that circle. And we'll talk more about that on Monday. But right now, all you really care about is that in this right triangle here that we made out of this terminus, x is this one, y is this one, and r is this one. And if you notice, if you think about it for a second, opposite, adjacent, and hypotenuse, the opposite side is y, isn't it? The adjacent side is x, and the hypotenuse is r. And if you were to rewrite these with the SohCahToa definitions that we talked about last week, anywhere you saw an opposite, that's just y. Anywhere you saw an adjacent, that's just x. And anywhere you saw the hypotenuse, that's just r. And it's the exact same thing. And basically, if you're going through and you're doing this and you're thinking about it, you don't need to memorize two different sets. Maybe you like x, y, and r better. Less to remember. Maybe you like opposite, adjacent, hypotenuse better. It's what I'm used to. Great, cool. Keep whatever you like, but I wanted to show you these just because somebody out there thinks it's important enough to force you to learn it. Here you go. You want to be able to see this. Really, eventually, when you do more deeper trig type stuff, that's when these become super duper important. For right now, as we're just sort of getting used to things, if you want to keep going with SohCahToa and just sort of put this off to the side in your notes and put a little cloud around it and say someday, then great, cool, that's fine. But pretty much everything that we're going to be doing is still going to be centered around SohCahToa, to be honest. Especially for the next couple weeks, if we're doing anything with trig triangles, I'm going to say SohCahToa. All right? But let's do some problems. Take a look at what they give you. They're going to give you an xy plane. They're going to give you a terminus. And they're going to give you a point. And then they're going to tell you which trig function they want you to find. So I'm going to draw a terminus and an xy plane. I'm going to make this as good as we can. Make this a different color so that we're going to make this a different color. There we go. Okay, so we're going to use this a whole bunch. So they'll give you this, and then they'll say this is the point 12, 12. This is, if you are looking at the assignment that I put up, the PDF, this is number 1. And what they want is they want the sine of our angle. All right? Now, as we go through, all we are doing is just making our triangle and then finding the sine. So, like, you could go through and you could say, right here, here's my triangle. And then, what's the x value? It's 12. What's the y value? It's 12. And you don't even have to think about it. Here you've got your triangle, right? And I just want the sine of this angle. So let me do that now. Sine, that is opposite over hypotenuse. Well, I know the opposite side, that's 12. But I don't know the hypotenuse side. That's not 12. That's this side over here. So, in order to do everything right, I need to use the Pythagorean theorem. So I know a squared, I know b squared. I need to find the hypotenuse here. So we got 144. That's a 4. So we got r squared equals 288. And I'm going to be honest, you leave it here, you're probably fine. But if you remember, hey, look, right isosceles triangle, I know this is 12 radical 2 when you break it down. Right, 144, you square root that, there's a 2 left over in there. But either way, look what you get. You get 12 radical 2 for your radius, for the hypotenuse. Right? And then you can simplify that if you want to. I'm going to be honest with you. You give me that on a quiz, you know you got your points. So the one thing that we need to talk about now, since we are on the XY plane, is how do we know things? Yep, same thing as we've been doing, right? Same thing as we've been doing, just doing the exact same thing, creating and labeling the triangle and then just solving it just like we're used to. The one thing that's going to be different as we go through these problems is we have to ask ourselves, is the answer positive or negative? So, thing number one, if we're talking about the radius of a circle, that's always positive. That's always true. So this hypotenuse here is always positive. So if you're doing a problem like this one on a quiz, you don't need to worry about positive or negative. You know that if you're finding something, it's just the hypotenuse. Everything else is given to you. Just follow what they give you, and then you can move on from there and trust in the process, okay? Just for GP, hopefully everybody knows the 12s cancel out. 1 over radical 2, and then you can rationalize that denominator and get radical 2 over 2. I will tell you in advance, for me, you don't need to rationalize anymore because we are grown now. We don't need to be doing rationalizing. Rationalizing is great as a skill because sometimes it does help us get things into a form that is more useful. When you take calculus, there's going to be this one problem that everybody learns about finding the limit of this one function that is hard to do because you can't do it without this, and they teach you how to do it by rationalizing the numerator. And the thing of it is, that's like the one situation where it's like, I need to do this tricky algebra trick to to figure out what the answer is the way it needs to be. But in here, we don't actually need to do that. All right. Let's do a couple more because I want you to experience the whole negative situation going on. Let me actually see if I can just copy these so I don't have to reinvent the wheel every time. I just want one. Let's get rid of all that. Hey, look, I did it. All right, now get rid of that because I do need to put it in a different spot. So let's put it over here. If you're following along, I am now doing number 3. And notice that the point that they give us here is the point -5, comma, radical 11. So once again, it does help if we take a second and make our triangle. And we always want to use the central angle here as our working angle, okay? So here, and again, it's backwards. Ain't nobody want that. We know that this is -5 according to the x value, and this is radical 11 according to the y value. So if you need to, take a second, redraw your triangle so that it matches expectations. And then that's the great thing is like you can get 3/4 of the way through here without even needing to know what it is that you're solving for yet. We're going to be finding the cosecant. And remember, cosecant is 1 over sine, so hypotenuse over opposite. And we know what the opposite side is. It's radical 11. But we don't know what the hypotenuse is, so we do need to do a Pythagorean theorem here. So you may need to find the radius, right? If we're doing sine, cosine, secant, or cosecant, those require the hypotenuse, right? Tangent and cotangent, you only need the opposite and adjacent, and that's what they give you anyway. So that's even less work for you, right? But so, okay, so let's do the Pythagorean theorem here. A squared plus b squared equals c squared. So -5 squared is +25. Remember, you always get a positive out when you square something. Radical 11 squared. Remember, the radical and the square cancel out, and you're left with 11. And then add everything together. Square root. And you know that the radius is always positive, so you don't need to account for the fact that it's negative. Radius is always positive. So the radius is just the number 6. So now look, I know what the hypotenuse is. It's that. The answer sheet here on the notes rationalizes it, so you would see the final answer of 6 radical 11 over 11. But if you give me 6 over radical 11 on the quiz on Friday, you know that you are getting full points. All right? How are we feeling so far? Do we want to do a couple more of these? Cool. Let me do number 6. Number 6 is the one we're going to do next. So this one This one gives us the point 7, comma, radical 15, right? So here's the great thing. We go through and we do this. Look at what we get. Same thing here. This is your y value, radical 15. This is your x value is 7. Do we need to figure out what the hypotenuse is for this one? Do we need to take a second and figure out the hypotenuse for this one? So for number 6, remember we want the tangent of theta, right? So why do we not need to find the hypotenuse? What is tangent? Yeah, exactly. Opposite over adjacent. And we already have those. We already have opposite. We already have adjacent. So it's just radical 15 over 7. Now here's the thing. Here's the thing. When we go through tangent and cotangent, literally you've got the two answers already. Just put one over the other as appropriate, and then you're done. All the other ones, if it's not tangent and it's not cotangent, use the Pythagorean theorem, find the radius real quick, get your hypotenuse, and then put the 2 over that you need. And literally for all these, that's all it is. Okay? How are we feeling? Do we want another one? Just one more. Got you. Let's do one of the ones where we have to find the radius again. So let's do number 7. Number 7, we are trying to find the cosine. I'm going to write that down right now so that we don't forget. And the point that we are given is the point -6, comma 4. So take a second, see if you can get it, find the hypotenuse, and then figure out what the cosine is. Let's go back to like the very beginning with this. You're given this point right here, this -6, comma 4. And the thing I want to do is I want to find the cosine of my angle at that point. So from there, let's turn this into a triangle. We want to use that central angle so that we're doing the right thing. Here's our x value, which is -6. Here's our y value, which is 4. And basically, we just made a right triangle, right? At this point, now that we have made our right triangle and put it all together like that, we can stop worrying about anything being different. It's all the same as what we were doing on Monday. The only real difference if you want to call it a difference, is the fact that, see how one of these sides is a negative number now? Okay, so it's a negative number, who cares? So look, we want cosine. Well, cosine is adjacent over hypotenuse. If you notice, we've got the adjacent side, but we don't have the hypotenuse side. Just like we did Monday and last week, if we don't have a side that we need, we use the Pythagorean theorem to find it, right? So a squared plus b squared equals c squared what is that? That's 52, ain't it? And then we square root whatever that is. I think 52 is 4 times 13, so we can break this down to 2 radical 13 technically. But again, like I said before, if you end up with just leaving it as radical 52, I'm not going to fuss over that too much. That's still correct. But now we're just going to do adjacent over hypotenuse like we're used to. Adjacent is negative 6. The hypotenuse is 2 radical 13. And then, again, like before, I don't really care if you rationalize it. Maybe, I don't know, take an extra second to simplify the fraction. But that is your final answer there. And that's all that it's asking you to do. Does that feel a lot better now? How'd I get negative 3? So look, you see how there's a 6 on top and a 2 on bottom? The 6 cancels out with the 2 and leaves behind a 3. But like I said, do I care if you simplify your fractions? I don't care if you simplify your fractions. If you got this, you know you're getting the same number of points as if you got this. Yeah? All right. Hopefully we're all feeling good about it. Any questions? Cool. All right, let's do the other one now. Now, the other one is now, instead of being given a point, I'm going to do like I was doing last week, and I'm going to give you the value of a trig function. The thing of it is, now that we're sort of any old place here on the XY plane, we just have to be very careful about our negative signs as we go through. So, what I'm going to tell you to do is I'm going to give you one trig function, and I'm going to tell you about sine or cosine being positive or negative. So here I'm telling you that the cosecant is negative 5 over 3, and the cosine is positive. So when we go through and we find our missing side, we have to take into account what we're being told right here. So let's build our triangle, just like we're used to. Again, this is nothing different than what we were doing on Monday or last Wednesday, right? Cosecant is hypotenuse over opposite. No, Yeah, over opposite, hypotenuse over opposite. And we just want to make sure that we put everything in the right spot. Now, I did say something a couple pages back that we're going to have to pay attention to. Somewhere in here, maybe. Remember that the hypotenuse is always positive. So here's the thing. You look at this cosecant. Remember that cosecant is hypotenuse over opposite, right? This negative sign has to go somewhere. So does it have to go on top or does it have to go on bottom in order to be right with our ideas here? Top or bottom? Which one of these is not allowed to be negative? Is it the hypotenuse or the opposite? Hypotenuse is not allowed to be negative, so that negative sign has to be where? On the bottom. Very good. So it will be very helpful for you to write it like that so that you know what's supposed to go where. Okay? So that goes there. That goes there. And I need that. I don't have it. Because I want to write all 6 trig functions. Just like you've seen on Math Excel. It's like, hey, give me all 6. Okay, here we go. So I need to have the adjacent side before I do anything else. So let's use the Pythagorean theorem. Look what I get. And like I said, when you're doing this, start here. Make sure to write down the positive or the negatives, and then come back to this thing right here so that it can tell you the right thing. Cosine is positive, so that means that x has to be positive 4. All right, now we just want to do all of our trig functions. Sine, opposite over adjacent, the opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. The flip of sine is cosecant. So we got negative 5/3. The flip of cosine is secant. So it's 5/4. And the flip of tangent is cotangent. So it's negative 4/3. We're going to do a bunch of these, so don't worry. But basically, 2 steps. Yes, we have to do this whole thing because the directions for the question are find the exact values of all the trigonometric ratios not given. So they're going to give you one. Technically, you don't have to repeat cosecant, right? We were given cosecant. But for your final answer, you need to tell me sine, cosine, tangent, secant, and cotangent. But I just write all 6 so that I don't forget any. I'm the type of person where if I start doing it where I just leave off the one that was given, I'm going to be forgetful. So I always write down all 6 just so I can be sure that what I did is exactly what needs to be done. Okay? All right. Let's do a bunch more of these. Let's do one where I'm given sine. Okay, well, let's do number 25. All right, so for number 25, we're given the sine is -3/5, and we're told that the cosine is positive. So now, again, that negative sign has to go somewhere. Is it going to go with the 3, or is it going to go with the 5? It's going to go with the 3. Exactly right, because the 5 is the hypotenuse, and that can't be negative, so we're going to put the negative sign up top with the 3. Do this step if you can so that you can be sure that what you have is right. So we draw our triangle now. Opposite over hypotenuse, and this is the thing we don't know, the cosine. So let's figure it out. A squared plus b squared equals c squared. Then do it out. And we're here, and I need to know, is x going to be positive or negative? Which one? Positive. And we know that because cosine is bigger than 0. So we know that x is positive 4. And so now we can just write out all our trig functions just like we did before. Sine is -3/5. Cosine is 4/5. Tangent is -3/4. Cosecant is -5/3. Secant is 5/4. And tangent is -4/3. And that right here is my final answer right here. All right. Now, here is the one that I know is going to cause confusion. So I want to go over one like this too. Goodness. All right, let's try that again. They give us tangent is 3/4. They give us that the sine is negative. All right, now, does anybody, in looking at this, feel their spidey senses tingling? Take a look. We got tangent is positive 3/4, and the sine is negative. Does anybody see something wrong with that? All right, talk to me a little bit about what makes that weird. Sine isn't the opposite of tangent. Okay. So the thing of it is, if we're to hold both of these factoids together in our brain, there must be something missing, right? Because you would expect sine and tangent to be the same side, because if sine is negative, then the opposite side better be negative, right? But that doesn't make sense because this is supposed to be positive. Yes, exactly, Ulysses. They can't both be positive and have the hypotenuse be positive too. It doesn't work, right? So that means that opposite and adjacent both have to be negative. Basically, you want to think about it like you were given the simplified fraction, right? Whenever you've got a negative on top and a negative on bottom, they cancel out, right? So the thing of it is, if you think about it like, oh, they just canceled it in advance and we have to go back and find the negatives there. So if your tangent or your cotangent is positive and your sine or your cosine is negative, then that means that it might be a really good idea to rewrite that positive number as -3 over -4. And we can do another one of those just to show you if you would like. Opposite over adjacent. We do the Pythagorean theorem. Hopefully we know that this is going to be 5. We've done a lot of 3, 4, 5 right triangles because 3, 4, 5 right triangles are easy. And then now that we have that, we can do all of our trig functions. Sine is -3/5. Cosine is -4/5. Tangent -3 over -4. That's why it was +3/4 to begin with, is because then two negatives canceled out. Cosecant is the flip of sine. Secant is the flip of cosine. And tangent and cotangent are flips too. So where did 5 come from? So remember, I don't know what this is yet. I got to use the Pythagorean theorem. Right? You get 25, and then when you square root it, and you know that r is always positive, and you get 5. All right? We're going to do a bunch more because I want to show you the ones that are tricky, the ones that you have to like do the lateral thinking for so that you see them all. Here's another really good one. Take a look at that. What's wrong with this one? Why is this one confusing? there's no opposite, right? All you see is the hypotenuse. It's not in a fraction form. So how can I take -3 and rewrite it so that it's a fraction? Yeah. Put over 1. And then remember, the hypotenuse isn't allowed to be negative, so we're going to have to put that on the bottom, right? That negative sign goes on the bottom. And then, now that we've done that, it's the same thing as all the other ones. Your hypotenuse is 3. Your adjacent is -1 because this is secant. And so we need to find what the opposite side is. So we go do the Pythagorean theorem. A squared plus b squared equals c squared. Subtract the 1. Square root. And again, you can leave it as the square root of 8, or if you feel good about it, the square root of 8 is the same as 2 radical 2. And is it positive or negative for this one? Negative, exactly, because sine is negative. Sine is less than 0, so y has to be -2 radical 2. And again, if you put radical 8 instead of 2 radical 2, you know you're still fine. And then you write out your sine, cosine, tangent, secant, cosecant, cotangent. Negative over a negative is a positive. Remember, secant is the flip of cosine. Cosecant is the flip of sine. And cotangent is the flip of tangent.